Hey, Engineers Roll community. So, I wanted to tell you guys when I went to go and make an example showing the 3D texture tool, I figured I'd get something from grabcat.com, something that might naturally feature a neural. So, what I found was a Dart model made by Mr. Alam here, and I downloaded that and I added a neural pattern to it using the 3D texture tool. Now you'll see in Mr. Alam's description here, he says that he made this file in SOLIDWORKS 2014. So as you know, SOLIDWORKS 2014 is now 5 releases back, and as the 3D texture functionality is new in SOLIDWORKS 2019, this is something he might have used in this example if he was making this in SOLIDWORKS 2019. So again, quick shout out to Mr. Alam for providing the model. Quick shout out to grabcat.com. It's a great online model repository if you're interested. This isn't an ad or anything like that. I just wanted to give a quick plug for a site that's offered me so much content. So without further ado, here we go. So in short, this is where we're headed. If you look at the screen right now, we have 3 3D printable versions of a design. We have a blue version, we have a red version, and we have a green version. We can 3D print these designs and we can photo render them as we have the 3D CAD models using either PhotoView 360 or SOLIDWORKS Visualize. So now the question is, how did I do that? Well, it's easy. To make the 3D texture, all you need is a grayscale height map image. So you take your grayscale height map image. Wait. Can we actually talk about what a grayscale height map image is? It's not really something I went to school for, so I think it would be useful to discuss. Yeah, so if you search height map on Wikipedia, you'll find a page all about grayscale height maps. It's important to note that SOLIDWORKS didn't invent the concept, and grayscale height maps have been used long before SOLIDWORKS incorporated them in SOLIDWORKS 2019 for modeling usage. Grayscale height maps are used in all sorts of contexts, but they are used a lot in 3D computer graphics, as you'd imagine. The idea is generally the same. You take a raster image, which is a pixel-based graphic. Each pixel has its own values, its own lightness and sort of darkness values. And based on the image itself and the mappings of these pixel values, it interprets, it being SOLIDWORKS in this case, the program interprets shadows and interprets depth, where in SOLIDWORKS' case, it allows it to take certain areas of that image and understand that it should leave certain areas as peaks and certain areas as valleys, raising certain areas so that you can get that nice 3D texture that you can 3D print. So this is a spot where I actually found a neural pattern, a grayscale image of a neural pattern on Google Images. So I just downloaded it as a JPEG, and now I'm incorporating it as part of a SOLIDWORKS appearance. Which you could do in any version of SOLIDWORKS, where you basically take a JPEG or a PNG and you apply it as an appearance over a face. So that's exactly what I've done here. The only difference is now I'm right-clicking a body and I'm telling it to make a 3D texture from that body, which is new in SOLIDWORKS 2019. So this here I have a couple values such as texture refinement, offset distance, maximum element size that really influence the resultant texture of it. And then as you'll notice the cursor feedback where it shows that we have a 3D texture body. I can then take that 3D texture or graphics body and convert it to a mesh body, and that's where I get myself in a position to 3D print it. Hey, so do you feel like you learned anything from that article? Well, if you did, the best possible way you could pay me back is to share this article on your LinkedIn and Twitter feeds. As a reminder, you can follow me at ServicePackSean on Twitter, and feel free to connect with me on LinkedIn for future updates directly from me.